Section 4.5, the derivative of the natural log of x. So let's just give the derivative of the natural log of x. So if I want to take the derivative of the natural log, I claim that the derivative of the natural log of x is just going to be 1 divided by x. Now, we do need to make sure that we recall that x has to be strictly greater than 0, and that's just because of the domain of natural log. Otherwise, none of this makes any sense. Once you have the derivative of natural log, then of course don't forget that you could have chain rule applied to the natural log. So if I have the function natural log of g of x, and I want to take the derivative of this thing, then what happens is chain rule. So the derivative of the outer function is going to be 1 divided by g of x, because the derivative of the natural log is 1 divided by whatever goes into the natural log, times the derivative of the inside function, but in this situation the inside function is g, and so that's going to be g prime of x. Then, if you wanted to clean this up, it's true that this is then g prime of x divided by g of x. So now chain rule. There it is. So then let's say I want to differentiate some functions. So let's just find y prime, given that this is our y function. Well, the derivative of sums is the sum of the derivatives. We're still good with that, hopefully. And then the derivative of a constant times a function is the constant times the derivative of the function. But now that I have natural log of x, I just take the derivative of natural log of x, which is 1 over x. Then I have the derivative of constant times e to the x. That's going to be minus 3 times e to the x, because of course the derivative of e to the x is e to the x. This one is the part where don't get messed up. Natural log of 4 is just a number. And since natural log of 4 is a number, that's a constant. The derivative of a constant is 0. Then I've got minus e to the 5th, once again. That's a constant. And the derivative of a constant is 0. So then I've found my derivative. We can clean it up a little bit. That's going to be 12 over x minus 3 e to the x, and we found our derivative. If I want to find the derivative of y is equal to the natural log of x cubed plus 6x, notice that this is a composition of functions. If you would like to consider it as the natural log of some g of x, where specifically g of x is equal to x cubed plus 6x, then we can find g prime, and g prime of x is then going to be 3x squared plus 6, and so you can do the chain rule then. Well, then we get y prime. Well, y prime is then going to equal 1 divided by the input of natural log, which is x cubed plus 6x, times g prime, where g prime we now know is 3x squared plus 6. If you so desire, you could clean it up a little bit. That's 3x squared plus 6 all over x cubed plus 6x. And so there we are. There's our derivative. Recognize here that we have two things going on. We have a product rule, and we also have a chain rule. So be careful. But if I want to find y prime, then y prime is going to be, leave the second function alone. That's going to be the natural log of 3x times the derivative of the first function, which is going to be 2x plus 5. Then leave the first function alone, x squared plus 5x, times the derivative of the second function, but this is our chain rule, and so that's going to be 1 divided by 3x times the derivative of the internal function, which is 3x, and so the derivative of 3x is just 3, and so this is what we get. Then let's see if we can clean it up at all. This is then, I'm just going to leave natural log of 3x times 2x plus 5 alone for the moment. See if we can get some more to clean up. And then notice that 3 divided by 3 is 1, and so that's 1 over x, which really means that this is plus x squared plus 5x all over x. But that will reduce. This is then the natural log of 3x times 2x plus 5 plus x plus 5. You could write this one more way. You could distribute the natural log of 3x over that binomial, and this could be 2x natural log of 3x plus 5 times the natural log of 3x plus x plus 5, and there's no like terms. This was just a different way to write it. At some point, you can just make your choice on which you prefer. At this point, we want to continue taking derivatives, but I want to remind us that we have some logarithm rules that you can use to change the way this function is written if you so desire. And so I'd like to remind you that if you have the natural log of products, that's the same thing as the natural log of x plus the natural log of y. If you have the natural log of quotients, that's the same thing as the natural log of x minus the natural log of y. And I can also remind you that if you have the natural log of something raised to a power, that's the same thing as the power times the natural log of that same something that you had before. And so, using the properties of logarithms, we can definitely rewrite some of these things if you so desire. It just becomes a matter of preference. Now this next one, if you think about that, notice that this is currently a chain rule inside of a chain rule. But there's a way that I can take away one of those inside functions. And so, first off, this is the exact same thing as the natural log of 3x plus 7 all raised to the 1/2 power, right? And so notice that the outer function, well, the inner function for natural log is the square root. But then inside of that is 3x plus 7. So you're going to have to do a chain iteration twice, or if you would rather, you can use that power rule for logarithms. And then this becomes the exact same thing as 1/2 times the natural log of 3x plus 7. At this point, recognize that if you do it this way, you only have to do the chain rule once, because a constant times a function, the derivative of that, is just going to be the constant times the derivative of the function. And so then I can say that y prime is equal to 1/2 times the derivative of natural log, which is 1 over the inside 3x plus 7, times the derivative of the inner, but that's just going to be 3. At this point, we would try to clean it up a little bit. That's then 3 over, and I'm going to distribute that 2. That is 6x plus 14, and there's our derivative. For the sake of seeing why I made that choice, let's just start with this. Well, if I decide to take that derivative, that's chain rule. So what's that going to look like? That's going to be 1 divided by the square root of 3x plus 7 times, but then I need to take the derivative of 3x plus 7 square rooted, but square root of 3x plus 7 is really 3x plus 7 raised to the 1/2 power. And so then that's going to be 1/2 times 3x plus 7 raised to the negative 1/2 power times, then I take the derivative of that inner function, which is going to be times 3. At this point, we got a little bit of cleaning up to do. This is then, the 1/2 is, I'm just going to shift it out front, and I'm going to move that 3 out there. So I got 3 halves over here. So there's 3 and this 1/2. But then I've got 1 divided by the square root of 3x plus 7 times, well, 3x plus 7 raised to the negative 1/2 is the same thing as 1 divided by the square root of 3x plus 7. Then fraction multiplication, this becomes 3 divided by, but when you multiply radicals, as long as you have the same index, then you can multiply the insides. But then it's 3x plus 7 squared, square rooted. Square root undoes the square, and so that's just 2 times 3x plus 7. And now it's more recognizable as the exact same solution we found above, 3 over 6x plus 14. Exactly the same outcome. Maybe the logarithm rules are your friend. Alright, so I've got number 5 here. This time I'm going to find the derivative as is, and that's going to be a quotient rule inside of a chain. And so if I want to find y prime, that's going to be equal to 1 over 3 divided by x times the derivative of the inner function. Honestly, I said quotient rule, but 3 over x is the same thing as 3 times x to the negative 1, so then I can use the general power rule. And so that's going to be times negative 3 times x to the negative second. At this point, this is then going to be, well, 1 divided by 3 over x is, multiplied by the reciprocal, x over 3, times negative 3 divided by x squared. At this point, 3 divided by 3 is 1, and so I'm left with that negative. X divided by x squared leaves me with 1 on top and x on the bottom, and so I get negative 1 over x. Well, let's use some logarithm rules to confirm that and see if it makes our life easier. So let's rewrite natural log of 3 over x. Well, using our logarithm properties, that is the natural log of 3 minus the natural log of x. Well then, let's take that derivative. Well, y prime is then going to be, the derivative of a constant is 0, minus the derivative of natural log of x is 1 over x, which is negative 1 over x. I sure did like that second way a lot better. But it's up to you entirely. I've got one more for us. Notice that this one is chain rule with a product rule with a chain rule. Or we can use the properties of natural log. So why don't I do it the long way first, and then I'll rewrite it using the logarithm properties to show us that we'll get the same thing. So if I just jump right in and I find y prime of what's given. First off, chain rule. So this is going to be the derivative of natural log 1 over x times x squared plus 3x raised to the 9th. Then times the derivative of the inner function. But notice that the inner function here is a product. And so let's be careful and not get lost. Then the product here, leave the second function alone. That's going to be x squared plus 3x raised to the 9th times the derivative of the first function, which is the derivative of x is just 1, plus, leave the first function alone, that's going to be x, times the derivative of x squared plus 3x raised to the 9th. That's a chain rule again. And so then that's going to be the derivative of the outer function, which is 9 times x squared plus 3x raised to the 8th, times the derivative of that inner function, which is then going to be 2x plus 3. At this point, I'm surveying my results and watching for some major mistakes. But let's try and clean it up, and then we'll double check ourselves by using the logarithm properties. So this is then, I'm going to put these denominators all the way across. That's going to be x squared plus 3x to the 9th over x times x squared plus 3x to the 9th plus x times nine times x squared plus 3x to the 8th times 2x plus 3, all divided by x times x squared plus 3x to the 9th. Well, x squared plus 3x to the 9th divided by x squared plus 3x to the 9th, that's 1. And so that's going to give me 1 over x. Then I see that x divided by x is 1. X squared plus 3x raised to the 8th power is going to cancel with 8 of these, and so I'm left with 1 power down there. And so then we're left with plus 9 times 2x plus 3, all divided by x squared plus 3x to the first. At this point, I don't currently see anything jumping out at me as more simplification that makes anything better. It's true that you could find common denominators and simplify them, but since we were just trying to find the derivative, I do believe this is the derivative. But I claim we can use the logarithm rules to rewrite this y function and make our lives easier. So let's do that. If we use the properties of logarithms, this is then going to be the natural log of x plus the natural log of x squared plus 3x, all raised to the 9th, be careful, that's x squared plus 3x to the ninth inside the logarithm. Then I can do this a little bit further. I'm not going to be able to do anything with natural log of x, but a power on here will come out front, and so that's going to be plus 9 times the natural log of x squared plus 3x. I don't see anything else jumping out at me that will help simplify this any further, so now I'm just going to take the derivative of this. Hopefully I get the exact same thing I did just a moment ago. So y prime, that's going to be equal to, the derivative of natural log of x is 1 divided by x. Then I have a constant times the derivative of the function, so that's just going to be plus 9. Then natural log of x squared plus 3x, not going to avoid it, it's chain rule. And so that's then going to be 1 over x squared plus 3x times the derivative of the inner function. But the derivative of the inner function here is 2x plus 3. And notice, oh happy day, I got exactly what I was hoping for. It's 1 divided by x plus 9 times 2x plus 3 all over x squared plus 3x.